Good morning, good afternoon, good evening. Welcome to Red Hat Live Streaming. I am Chris Short, host with the most of the channel, and I'm joined today today we're talking data services, particularly data science. I'm joined today by Sophie Watson and Audrey Resnick. How are y'all today?
Doing pretty good. So greetings from Arizona. If anybody's in Arizona. Yeah.
Is it warm there still? I guess is the question.
It'll get up to 100 today. It'll be just
Ouch.
a little bit tasty.
Okay.
Remember, it's a dry heat.
I know that it's a dry heat. I've been in the dry heat. It's when the dry heat sucks all the water out of you. That's when it's a problem.
Yeah, you just have to remember to keep on hydrating.
Yeah, there you go. Sophie, we are talking about day-to-day data science, which almost is a tongue twister. I like how you did that there. So how are you, Sophie?
Very well, thank you,
Very
Chris.
well.
How are you?
I'm fantastic. The fire is going in the background because it's only going to be a high of 70 today. It is officially fall here in Michigan.
Nice. Very jealous. It's going to hit 100 here as well.
Oof.
So
y'all can keep that.
Thanks.
I will stay up here north of Canada. Thank you.
So we wanted to talk. I know we've had a few sessions where we chatted about data science and all things data science, and we focused on data engineering last month with Carl and Guillaume. So obviously, if people missed that, go check that out. That was a pretty good discussion. But I feel like people don't know what data scientists actually do. So Chris, what do data scientists do?
Y'all do data.
Actually,
no, I mean, to an extent, I do know what you do because I have worked with data scientists in the past in some of my DevOps roles, like getting them to learn how to use containers to run their models and run everything kind of at their own pace. So I know that you look at a ton of data, you create algorithms or use algorithms to kind of parse and, find things within the data that can help organizations down the road kind of deal and maybe detect future things. It is pretty opaque to me, I will say, because a lot of math is involved. And I have if there's a phobia of math, I have it. It took me 10 years to take an algebra class. So yeah, it's pretty bad. Anyways.
How many fingers am I holding up? No.
5. I can count. If we get past the basics of the little calendar in your OS, right? Cosines, no, lost on me. Algorithms, not lost on me. I kind of get sorting algorithms and stuff like that. I get that, but the whole thing with sand doing math, that whole thing. No, I have no. I don't have any desire to learn that level of math detail. Yeah.
So I think that's interesting. You've hit on a few points there when you talked about what data scientists do.
Mm-hmm. Did I offend you? I'm sorry if I did.
No, not at all. But I think it plays into where I want to take this. So you gave this really nice overview of we explore data, we try and find patterns in it. Mm-hmm. We might use an algorithm, which, most people just say model, but we might use, an algorithm or a model or a process to explore that data. And then you also said that we might make predictions using that. We might try and predict the future.
Uh-huh.
So I like that a lot because I think there's this notion that all data scientists do is just train models.
I don't think that's the case. I think there is a degree of you have to do that in your work, right? There's some churn, right? There's a grind to your work, and then there's the actual discovery phase, the aha moment, right?
Right.
I was just going to say, I think that kind of describes it well too. The one thing that I think most people don't realize is how much time we spend with our customers trying to understand what their problem is that they're trying to solve. Mm-hmm. And that leads us to ask more questions of the data. And I always look at the data and tell the customers the data is going to tell a story, but I need to ask you questions. How do you use the data? What are you hoping to use this data for? So besides the mathematics, there is a little bit what we call almost domain expertise.
Yes.
And that kind of almost gives a Venn diagram with domain knowledge, mathematics, and then programming. And then in the center area is kind of where your data scientist sits. But I don't think that's the whole story. Because sometimes data scientists, they don't end up creating a model. They may look at all of the data and what the user is trying to accomplish, and they may say, well, you can solve your questions here just by using Tableau. And
right. Sometimes
it's,
there's tools that you already have that you could throw your data at. Yeah,
that's correct. Yeah.
Right, and there's a lot of data scientists for whom the role isn't to ever train a model and make predictions. It is simply to kind of produce reports and process that information that you then pass back to stakeholders so that they can make some decision.
So,
yeah.
I mean, I traditionally see that as like a business analyst kind of thing. Do you see the two roles kind of merging, or am I just old in my thinking, I guess?
I think it's trendy to call everybody a data scientist. So I think that, yes, a lot of people that traditionally we might have called business analysts kind of 5-10 years ago are now feasibly called data scientists. It really varies from, company to company. When Audrey and I talk to our customers, you get such a range of what it means. Our first question is, some account team might call and say, hey, can you talk to the data scientist? So we'll sit down with the data scientists. And the first thing to say is, so what do you actually do? What do you think your job is? How do you spend your time?
Is it more like an interview than like a work session, or is it?
Yeah, I mean,
like it sometimes.
Yeah. Okay.
Yeah, it is like try to figure out what they do and then, what their pain points are. And then how, if we can sweep in with containers, like you said, and kind of ease some of the friction in their day-to-day going forward.
Yeah.
So,
I was just going to say, sometimes they know that they have a problem and they know that they can find it in the data. But when you start looking at the data, you can go, did you know that you could do this with your data? So for example, I worked with a mining company and they were looking at their data for truck optimization. And then they were saying, well, we have to spend $13 million and buy these new graders to like grade the roads. And I was looking at the data going, well, did you look at your data to see how much time your current machines are using? And they're like, no, we just know that they're all over the place, but we don't know if things are getting done. So asking the questions and probing is very important because sometimes you'll find these little hidden gems that your customer didn't know about.
Right.
And save $13 million.
Yeah. Like there's so much potential because you come in with like a fresh set of eyes, right? It's almost like a consultancy within a larger organization, right? Like, yeah, I know you think you need to grade the roads, but do you realize that road isn't used often, or something like that, right? Like,
yeah. Or did you realize that somebody's been taking a 2-hour break? They've just been sitting there in that spot for 2 hours. I don't know. Yeah.
Not me
either. No, absolutely not.
No, never you. No, never you.
My watch never tells me to move, I promise.
Chris, one of my friends just texted me to let me know that you're on fire and maybe you should do something about that.
It's digital, so don't be afraid, folks. It's normal.
Okay. Thanks for clarifying. So, Audrey and yourself, Chris, also talked about math, like maths, as Brits call it, comes into this. And I feel like there's two classes of people. One that think data scientists just train models, and the other that think that data scientists sit down and do like absolute extreme next level mathematics, pen and paper, Greek letters all day, every day.
Yeah, Greek letters all the time.
Greek
That's what I
letters.
figured. Yeah.
So I think it's important to understand what, when you choose a particular model or an algorithm, or you process your data in a particular way, it's important to understand the underlying mathematical assumptions and statistical assumptions that you're making about your data, or the relationship between variables in your data. But I don't know about you, Audrey, but I haven't sat down and written Greek letters on a sheet of paper for a very long time.
Yeah, I would have to say that that was probably 2 years ago for me. But then I do have some colleagues, ex-colleagues from the company that I worked for before. That yeah, they did sit down and do that. But I would say generally, that's very rare. I mean, you just don't sit down all day and churn out mathematical formulas or algorithms.
Yeah, if you're not sitting there churning out maths, then what are you doing?
Well,
training algorithms.
I would say when you look at a data science problem, 90% of the time is looking at the data and trying to understand it very well. So that means you could be maybe doing a number of small analytics where you're looking at some charts at some of the data or some graphs, and then going back and asking the customer questions. I remember one of my mentors from 5 years ago saying that if you get a problem and some data and you start within a week going ahead and creating a solution, you probably didn't spend enough time on the data. And I find that actually very true. Once you start miring yourself in the data and taking a look at the relationships between the different data and thinking about what the customer wants, you usually end up digging around for more data and going back to the customer and saying, I find this relationship, or I see the data telling me this. Is there any other data that you use that you haven't told me about? And I know for me, a lot of the times the customer would go, oh yeah, I totally forgot about this other database that we use to get XYZ, right? And then you're off again exploring the data one more time.
Is that, I mean, I gotta ask, is that frustrating to an extent, right? When people don't realize all the data they have and they give you a problem and they're like, or give you data and just like, hey, find something. And like, do you feel like you're kind of like needle in a haystack looking, or like hunting for ghosts sometimes, or is it?
That's probably what makes the data scientist, because we're kind of crazy. We dig stuff like that. I mean, no pun intended. That's, for me,
Sophie's
that's a lot of fun.
Ghost hunting later, or what?
Yeah, there you go. Exactly.
So
yes,
we say day-to-day data science, right? Like, what does a data scientist do day-to-day to help the organization, right? I know you said mire in data. I know that it takes, say, longer than a week to look at the data. At what point in time does an organization come to the data scientist and say, hey, we could really use your help right now? I mean, what do you do to make that connection between, what your day-to-day work is and organizational goals?
Yeah, so I mean, first and foremost, it starts with a lot of discussions, understanding what success means for the stakeholders, what they want to find out, what information they've got, how will you know if you've done a good job? When is enough? So I think it starts with a lot of discussions. Audrey?
Yeah, I would agree. I mean, you don't want to keep going back to a problem saying, well, if we had more data, if we looked at it this way, I mean, because you have to be cognizant of the amount of time that you're spending on a problem as well.
Right.
I mean, if you're spending so much time on the problem, maybe the cost of you working on it is going to not give you the benefits of just getting a short-term answer. And sometimes just getting a small answer, or if you did create a model, just seeing what the model generates for a few weeks can actually give you more valuable insights. So for all of those people that like looking at data, talking to different people, and trying to glean gems out of what your model may produce or what the data may tell you, come on in, be a data scientist.
So what are some problems that you've solved personally? I mean, I don't know if you can necessarily talk about all of them, but if you want to omit company names, feel free. I mean, what kind of evolutions have you started?
Yeah, I know for me, the most fun that I ever had with, I would say, a large data set and that kept on generating more opportunities was for an open pit mine. That sounds terrible, but it was for oil sands. And trying to determine, first of all, just the optimization of these large trucks carrying the actual raw material around on the roads. And the first thing that they were looking at is, can we optimize how the trucks take paths on the roads? And then it was apparent that sometimes when things were slow, it was really the road. So then how can I determine if a road is needing repair or needing a grader? And then it went to, how can I track my graders to see what kind of optimization is being done? So those are kind of very general, high level looks at what you can do. But I mean, that project for me lasted 1.5 years, just because we kept on finding more valuable insights as we went along. And I mean, we have to look, the first time we talked with this customer, they were saying, yeah, we want to do this. And we were scratching our heads and we're like, well, do you happen to have any GPS data? And they're like, oh yeah, we've been collecting that for the last 5 years, but we haven't done anything with it. Because each of the trucks that would go on the mine, they had a tracker, and each time they would pass a certain marker or checkpoint, you would get the speed of the truck, date,
how much
time,
fuel,
everything.
all that fun stuff, yeah.
So with the time and the speed, you could get distance, fuel consumption, everything. And they were just sitting on this for a number of years because nobody really knew what to do with the data. So for a data scientist, I think that's kind of the treasure chest of data science, where you can go into a problem and there's just so much to look at and so many insights that you can gain. And I would have to say the most important part of a data scientist, and Sophie, you can agree with me or give your input on it, is really sitting down with the people that are doing the day-to-day tasks. I'll add one more item and then we can put it over to Sophie. I remember talking to this one mine engineer and saying, well, how do you know where all the trucks are in the mine? And he's like, oh, well, on the back of my crossword puzzle, this page, I've written down where everybody starts, so I kind of know in the morning where this person is in this, 10 square kilometer area.
Yeah.
But then I have to jump in my pickup truck and track them. And I'm like, good God, there's got to be, an easier way that we can do this. And we could do that eventually, again, because we knew the GPS coordinates. We could find out where the person was within the last half hour. But these are the sort of things that you can find.
Wow. I mean, Sophie, I think of the UPS drivers never turning left or trying to minimize their left-hand turns as a data point for, fuel economy and everything. What kind of discoveries have you made in your, data mining?
Right.
And then I have a question from the audience to ask of both of you.
Oh gosh. Okay, I'm just going to talk for the next 40 minutes so we never get to the audience question. Sounds scary. So I think I should throw out a disclaimer that although my title is data scientist and I spend a lot of time with data scientists, we're often kind of helping them and advising them in their kind of roles and daily work. I've had some real fun thinking about recommendation engines in the past. So
Like for Amazon, or like just
well, I mean,
for anything?
right. So how many different things can we think we need recommendation engines for? Amazon, sure. So
My
what's the deal with
doctors.
Amazon?
Yeah, like
Right.
yeah.
So with Amazon, like, well, I don't know. What's the most frustrating thing about purchasing something from an e-retailer site?
When they recommend that I buy something similar after I've already bought the thing.
Exactly.
That's so annoying.
Buy a new ironing board, and then
it
all
recommends
of a sudden,
6 of them over the next week.
Right. Yeah. Okay. Versus think about something like a TV streaming thing. Mm-hmm. So if you watch a full horror show, it knows you've watched it.
Yeah.
Does it not make sense that it recommends something similar?
Something similar with the actors, the genre, there's so many data points to touch there. Yeah.
Exactly. So first up, even though at the end of the day we're just recommending, essentially we can think of all of these recommendation engines as just suggesting products to users. You've got to think about the domain, because in the movie case, we want similar things to continue to be recommended to the users, versus in the case of I just bought an ironing board, I don't want another ironing board because I just bought an ironing board. So I really like things like that. In terms of recommendation engines and algorithms and models, there's a known set of algorithms that people use for these. When I go and approach a problem like this, I'm not writing a new recommendation algorithm from scratch. Right. I'm not getting, the paper out and Greek letters and kind of making something up. There's known algorithms that will take for this. But you can't just throw your data in and expect a good answer. You've got to think about what you're gonna then return to the user, what's important and what isn't. And it goes back to that notion of how do I know if I've done a good job? So I think, the recommendation stuff was so fun, because at every facet, at every turn, there was a new facet to think about. Like you said in the films, do you recommend things with the same actors in them? Right, exactly. Or do you recommend things that are set in the same area? So when we moved to Oklahoma and then lockdown started, we decided we were going to watch every film that had ever been set in Oklahoma. I can let you know that we got 3 films in and didn't finish the 3rd film, but there's still hope. But things like that, there's so many facets of ways that you could recommend things and chain things together. Right. And then it falls down immediately as soon as you transfer that to a different domain, even though it's the same algorithm to recommend things. The other thing that I got really hooked on was Spotify. So Spotify has
Oh yeah. Okay, go ahead. Sorry.
I feel
I have a lot of beef with Spotify's recommendations.
You have the beef?
I have beef with their recommendations because sometimes the songs they recommend are not anything I would listen to.
Are you sure that some of your kids aren't actually logging into?
No. My account is safe from the kids. So
okay. So the thing I find fascinating about Spotify is the way in which it puts together these daily playlists, which are a mix of things that I've listened to before and I liked, but I've never told Spotify I liked them. So how does Spotify know that I like them? Any suggestions?
Data science.
Well,
throw that one out there.
I mean, if you've got a song that you like, then you listen to it a lot, right?
Right. Yeah. So the more you listen to it, the more, yeah.
Right. So it's not like when we buy something on Amazon or we watch a film and we rate it 5 stars. You don't really do that with music. You instead just listen to it a lot and perhaps in repeated patterns. And so it's incorporating that information in there. So not only is it saying which songs have I listened to before, it's saying which songs have I listened to many times. I always like trying to mess up the algorithm, see what happens if you put on a song that you don't like overnight, go to sleep, leave it on repeat in the other room. is that going to get into your algorithm the next day? Is that going to be on your recommended like daily playlist 1 in a week's time? Who knows? Figure it out. Try and like reverse engineer. How are they making these decisions? The other thing it does with those daily playlists, which is fascinating, is it kind of makes coherent playlists out of them. It's like somebody has sat down and crafted you a personal mixtape. And there's kind of 4 different daily playlists, and they all kind of cover similar genres, similar moods. And it's not always that like playlist 1 is pop, playlist 2 is rock. It blows my mind. I think it's so clever how they are using their recommendation engine. And then they're not just recommending things that you've never listened to before. So occasionally they mix them in. They've got some algorithm somewhere that's determining how often they mix in new songs to your playlist. But they're also recommending things that you've already listened to and putting those in your playlist as well. So again, it's different from the movie recommendations and the online shopping recommendations, where it's not going to recommend you things that you bought before, unless it's something like printer paper, in which case there's another algorithm running that knows that you need to buy printer paper like every 3 months because that was how frequently you bought it before. So basically, I think recommendation engines are fantastic. I'm going to stop my rant there.
Fine. So question, someone's curious. Is there a right path or known good path to switch from data scientist to ML engineer with ML ops expertise? I really enjoy training models and creating APIs. And also I would like that to take advantage of OpenShift to achieve that. So that's kind of like a long question to basically say, hey, is there a path for me to work on APIs more with my machine learning capabilities?
Audrey, you want to chat?
Say hi to Max back there.
Hey, Max.
Yeah, poor guy. Got 3 legs. I think that path is actually pretty seamless. It's very similar to kind of what I've done. You can start on data science, but if you kind of get interested in any of the ML ops, it's very easy to slide into that role. Right now, I'm working with a number of ML ops engineers, looking at how we deploy some of our models and what could be future best ways for deployment. So I would say the data science portion is actually very important because there are not too many, I would say, of us that span those multiple roles. And you can actually give very good insight into how ML ops is done, because remember, most ML ops engineers, they may not know a lot about data science. So they may not take into consideration that, you may want to say, use a couple different techniques for looking at your data, whether it's Grafana or whether you're using Apache streams to pull in your data. They're only looking at how you're doing your model delivery. And sometimes you have to look at how the whole picture is put together. And I would say that if you're looking to get more into ML ops, at least within Red Hat, there are a number of really good courses that you can take. There's like an intro to OpenShift, intro to Kubernetes, and then it just goes from there, and you can go down the ML ops stream. So I think that switch, again, very easy. It's a very good switch, and it makes you more valuable.
Yeah, I just dropped a link in chat for you. Hinch Avenues, maybe? I don't know. Don't know how to say that username, but I just dropped a link in chat for the Katakoda courses.
Okay. Chris, can I share my screen?
Absolutely.
All right, let's see if we can get technology to play. Can you see my screen?
Yes.
Okay, so
Lovely.
I think, I think when we think about ML ops kind of as the discipline and the process and of operationalizing machine learning, then it's a really important thing to think about. And the reason that it's tricky and the reason that there's this need for the ML ops engineer is because data science is hard, but data scientists aren't application developers. So we don't necessarily know best practices about things like version control, source control,
right,
kind of making code repeatable, you know,
mm-hmm.
in the same way that you'd want your standard application to be repeatable. It's really important that your machine learning code is completely repeatable and reproducible, and particularly in industries where things are audited. So for example, if I have to go back and say, why did I deny this person a mortgage on date X?
Right.
Then you've got to say, okay, well, what model was in production on date X? What data was that trained on? What particular parameters were running for that model, etc. And so obviously, like perhaps to us at Red Hat, that's where you think, containers and containerizing this, turn it into container images, everything's going to be immutable. That's really going to help the story. But I just like this slide because I think it captures kind of all of, well, not all of, but many of the challenges of reproducibility. And so I think if you have that skill of being able to produce these APIs, to kind of put these models into production and interact with the models, but you're also aware of the underlying data science, then you're in a really good stead to make sure that we don't make any silly decisions when we're going forward.
How much data science have you seen in medicine lately? I'm just curious from a personal perspective, having, you know, a couple of different injuries.
Exploding right now.
Is it? Okay,
really
good.
exploding.
Because I would love some kind of model to be able to tell me if I'm going to have a high pain day or a low pain day, right? Like something like that would be a life changer for me, because, you know, environmental conditions, you know, activity the day before, that kind of thing. Being able to tell me like, hey, you should be, you know, there's all these stats out there that people are looking at to say, hey, like that's the magic number for disabled people to look at. You know, if this number's low, you're good. If this number's high, you should probably take a break, kind of thing. And, you know, we're all searching for like the holy grail of data, essentially, to kind of give us an idea of how our body's going to respond. So I'm super curious about the medical sector in general, because I know, like, you know, gas, oil, natural resources, they all do it. I know shipping does it. Logistics is doing a ton of data, but there's like medicine is just this ripe area, I feel like, for a lot of improvement.
Well, I know medicine in particular, just within the last couple of years, they've always had a lot with imaging. And I would say that, not that that's the only thing that's really leapt into data science, but they've done a very good job of, say, taking, say, x-rays, looking at x-ray data, CT scans, or even video when they would use in colonoscopies to try to do anomaly detections, where they're looking for either cancerous tumors or benign tumors. That's actually been very useful. Or I know in the area of COVID, what they've done is they've taken x-rays of normal chests, those with pneumonia, those with COVID, and can they possibly create a model that could detect COVID very quickly? Right. And in that respect, they've done not too bad of a job with the data that they have. But remember, within medicine, it's just not only these x-rays. I mean, they're using it for DNA analysis. They are using it for heart analysis. I know, gosh, even like 10 years ago, there was a company that I was talking to that they were actually monitoring a person's heart rate from home. They would wear a monitor, and then based on an irregular heartbeat or something, somebody could check in with that person to make sure that they were okay. So, you know, data science has been around in medicine for a long time. And the things that we're seeing right now are great. And plus the health trackers that you're talking about. Right. There are tons of apps out there that you actually can just download and use.
Now, that being said, I think everybody can think of an example where AI has been ridiculously wrong. for example, if you train AI to determine, identify different types of footwear, so high heels, sneakers, football boots, etc. You could do that with photos. We've got object detection, so we can train a model. It's really easy to confuse that. All you've got to do is wear your high heels on grass, and it actually thinks that they're going to be football boots,
right,
because it's picking up the grass, which is usually in the background of football boots, rather than picking up something about the shoe itself. So, and I mean, that's just a benign example. There's chatbots that have gone very awry very quickly.
Yes.
So I don't know how. I wouldn't put my life in the hands of an AI diagnosis, but I think there is information that we can use, like you said, Chris, don't go outside today because it's awful out there.
Right.
That's, that's useful information, and that's not detrimental. Within reason, that's not detrimental to us as a human, versus if an AI says, oh, you need extreme surgery, but a doctor says, no, I don't think you do. Yeah. I'd trust the doctor. Hey, Carl.
Hey, Carl. Welcome. Oh, no, we can't hear you.
I hear you.
Oh, magic buttons to be pressed.
If only there was some AI that could...
right? Like I am talking and I'm on mute. It should just auto on mute.
Being late, having, I'm still on mute.
No, you're good. We can hear you.
Okay.
You're good. You're good.
Not only do I show up late, I show up with technical difficulties. Don't trust my my data science model right now. That's happening, I guess, is the,
hey, this is the moral of the reality.
Story. Yeah.
The reality coming in.
Yeah. So it sounds like we're talking about the appropriate use of models in certain situations. Is that right, or am I missing the beat here?
I think that works pretty well. Yeah. Chris was asking of healthcare use cases of AI. Audrey was talking about the really exciting work that's going on, the medical imaging stuff, all the forecasting and prediction stuff. And then I was just being a natural pessimist and saying, don't get ahead of yourselves, folks.
Mm-hmm.
I mean, that's the thing too, is sometimes the models that somebody comes up with, or some of the analysis, maybe just be on such a small subset of test data that when you're using it in a larger grouping, it totally gets it wrong. So
well, that's the thing, right?
As an opportunity to get it right. I don't know.
Yeah, and there's I'm not going to get on my soapbox, but there's a lot of scenarios that aren't accounted for in the collection of data sometimes, right? Like, is the person in a wheelchair, for example, and they can't reach a thing, and that's why they're not using it, right? Like stuff like that. Like the environmental things aren't taken into account, and we look too closely at if you drill too far down, you get data that's very skewed and kind of works for 80% of the world, but not the other 20% kind of thing. I feel like that is going to be a continuing problem in the industry, as I mean, the Theranos trial started. I'm just going to throw that out there, right? Like, there's only so much you can do with AI and ML right now, right? Like, you can't change all of an industry with it unless you truly are discovering some new way of doing things. That being said, are we in the right environment for data science to flourish and machine learning to flourish, or is it, in your opinion, a little too early for us to put full faith in our AI and ML? And it sounds like, I don't trust all the algorithms just yet from the Sophie perspective. I mean, is there anything, obviously the music suggestion engine works for you, Sophie, but it doesn't work for me necessarily. So
Well, it's got an easy job for me, really. It just has to recommend Taylor Swift songs on repeat. And I'm like, this is fantastic.
blow bar to clear. Got it.
Yeah. Well, I think people in general, they should be able to trust AI to a greater extent. I mean, you may not realize it, but on the highways, we do have a lot of autonomous trucks, especially in the Tucson region. There is a company that produces autonomous freight haulers.
Wow.
And they test those vehicles. And they haven't had any accidents in the last number of years. They've done testing through various weather conditions. Of course, weather in Arizona, mostly sunny, but you can get the dust storms. You can get our monsoons with rain. What
You've got
happens in the
mountains.
night?
You can go find
We've
some
got
stuff.
mountains.
Yeah.
Yeah. So there actually may be situations where you may not even be aware that AI is working well. And as well too, within the Imperial Valley within California, and here just outside of Yuma, we have a lot of agriculture that relies on AI in terms of moisture detection. Do we need to, water some of the crops? So there are a lot of things that AI is doing very, very well. But I think with any new technology, as soon as you start looking at something, there are going to be a few hiccups. So if somebody asks you, do you want to participate in this AI study, and you have heart issues or something like that, and they say, oh, by the way, you're going to be our first test candidate, that's when I would be pretty leery.
Right. Yeah, like read all the warning signs.
read all the warning signs for sure. Yeah.
Having just spent my weekend at a roller coaster park, or at least a day of my weekend in the roller coaster park, past the thrill level of 2, I shouldn't ride the ride according to the warning signs. So yeah. But that is just because, it's like, are you pregnant? Do you have spinal issues? Do you, it's like this list of things you should not ride. And it's literally on every sign on every roller coaster. So, it's one of those things where it's like, okay, I'm glad they put that out there, because otherwise, I'm just going off doctor's orders at that point, which were don't ride anything, So yeah, you can do the kiddie rides, Chris. That's okay.
Kiddie rides are fine.
Kiddie rides are fine. I just don't fit in them very well. Yeah. So, Carl, I haven't asked you many questions because you just got here.
Fair point.
Fair point. So, I mean, data science day to day, where are you seeing, actual like things happening with data science in the real world right now?
Yeah, no, that's a good question. I mean, as Audrey mentioned, there are fantastic examples of AI and ML, right, that are happening all around us, right? I mean, some of them are big examples, right? Physically big, like trucks on a highway, which is pretty, it's pretty interesting. But a lot of it too is, if you think about customer interactions, like interactions you have with shopping, right? You have, I guess, the music recommendation algorithm you guys have already discussed, but there's also, next best action type models that are out there. Like, what products can we recommend to a customer, and how can we recommend things in the moment, right? It's not how can we recommend things and then interact with a sales associate who then calls you later that afternoon and then says, oh, the item you're actually interested in is in stock. Please come back to our store to purchase that. Like that, the opportunity is already gone, right? Yeah. So a lot of I don't want to call anything easy, because it's not, right? I mean, it's the only thing that's easy about data science is introducing bias, right? We don't want that. Maybe the more straightforward things or models that I've seen a lot of interaction with are those models that exist in internet shopping, right? And surfacing recommendations, so recommendation engines and next best actions. Those are the good examples, because it's an in the moment decision. Your model will take the information it has, create an inference, present it back to you. And if, Sophie mentioned shoes, right? If I'm shopping and I see an advertisement for shoes, it's not that big a deal. It's not going to upset me, even though I have no interest in shoes, right? It's a benign example. So we see a lot of these where the model can act quickly, and even when it's wrong, the downsides are limited, right? So it's a very benign example. The ones the models that are getting all the headlines are the really big, hard to solve problems, like you've already discussed in healthcare, where that touches lives pretty directly.
Yeah, I mean, there was just a study I read that obviously used a ton of data to break down kidney function in patients that had COVID, and how like the long-term effects of COVID, it's starting to look like the data is indicating that it affects long-term kidney function. If you do get COVID, at a younger age, you might need a kidney replacement at a later age, is what it's starting to look like. So like that data to me is fascinating, right? Like the long-term effects of a novel coronavirus. Like that is truly interesting, because this is something that's going to be with us forever. We're not going to eradicate this overnight kind of thing. So yeah, learning the long-term effects of getting it is vitally important, because there's a whole class of people now that are quote COVID survivors, and they might have long-term issues if we don't go look at the science now, right, and start looking at it and seeing what's changing in those people that had naturally contracted coronavirus. Yeah.
Right. And that brings us back to kind of the two different types of data scientists, Chris, in my opinion, because the thing that you're talking about is kind of taking that data, analyzing it. There's no sort of pressure on time, and then making some conclusions in a report and then feeding that back to somebody, versus Carl talking about kind of the AI that's ingrained in these systems. So as a data scientist, we'd have to think, if we were trying to solve this problem, okay, well, which algorithms can I use? Because I could probably make a better recommendation if I had 3 weeks to churn all of this customer's data and every other customer's data and pass it through a really deep neural net, and then flip it and reverse it, and then do something else with it, and then come up with this recommendation for them. But by that point, they've already they're gone.
Right. They've had strategy changing sessions and all this other stuff.
Right.
Yeah.
So it comes back to kind of thinking about sitting down with the stakeholders, understanding what's important, how you'll define success in the project, and then figuring out where to go next.
Yeah, I mean, in both of these cases, right, it comes down to the quality of the data and being able to ask the right questions. I mean, you probably already talked about this since I'm late, but the real mark of a data scientist is coming up with appropriate hypotheses, being able to test them, and then understanding the impact for the inevitable iteration that's going to happen as we continuously improve these models. And with something like COVID and long COVID and all of the unknowns that are out there, I mean, we simply don't have enough data. We have intelligent people who can ask the right questions, so we're moving in the right direction. But if you think about longitudinal studies, I mean, a lot of these studies happen over 20, 30, 40 years. I mean, we're talking decades, right? So we're only scratching the surface on long COVID.
Yeah. And like the systems that are put in place today to start studying these things will still be like churning away 5 years from now to continue to study them, right? So
absolutely.
Yeah, it's pretty wild. So we got about 10 minutes left. Is there anything we want to share for that data scientist out there that's trying to break through in their work today and find something awesome in the data? Ask for more data. that just a stall tactic?
No
Give me
comment.
more data. Give me more data. I'm just kidding. Some of the things that I've seen, right, like in the financial sector with AI model or ML models, or just models in general, I should say, because I don't really know what I'm talking about, is, like person X like has these accounts, they probably would appreciate this product kind of thing. Or person Y is applying for a mortgage, so they need to like make sure their credit score is as high as they can get. So here's what they recommend doing, or not doing while you're going through the mortgage process, that kind of thing, right? Like, don't buy a car when you're trying to get a mortgage. Like, that's like great advice, because it raises red flags to the people in the mortgage business, right? So like I've seen those examples out there kind of in my day-to-day work. What other examples do you think are helpful for data scientists that they've created over time? Like the annals of data science history.
Well, I don't know what would be so helpful, but what I find interesting are just on our social media, how they've been changing their algorithms in the past couple of years.
Yeah.
Due to a lot of the unrest or disruption. I mean, they're taking a harder look at the emotion and the context of various conversations that are happening and flagging them. So whatever natural language processing that they're using for that, or what other algorithms they've developed, I think have been very interesting just over the past couple of years. And that's allowing a lot of those individuals within those social media companies to actually ban people or ban groups. I would say those are more visible, and those are actually more interesting. And I think it's good for a lot of the, the ones where they're actually banning a lot of people or groups, to provide just overall more stability and safety. Though other people will say, well, what about the freedom of expression, right?
Well,
so it's
safety first is what I always say.
Well, safety first, but yeah, it's an interesting discussion. I like the way that it's going right now. It's just it's very interesting.
Yeah, I mean, what I'm hearing you say, Audrey, is that as data science, artificial intelligence, and machine learning become more prevalent, right, we have the interaction of data and inference and modeling with society as a whole, and that's a whole nother topic that we could we could spend hours discussing. And that's a really cool thing. I mean, as it's a dynamic system too. So as society changes with data science and artificial intelligence, like, we're going to have to now go back and update these models, and it's a continuously iterative process, given that the interactions between everything here.
So it's funny that you mentioned social media. I have an opposing view. I like sports, so I get nothing but ads for sports books and casinos all day long, right? Like, that's it. That's all I see on Twitter for ads. Like when I'm using the native Twitter apps, it's just nonstop casinos and sportsbook. I am very much anti-gambling. So, right, like, gambling is an addiction. The models aren't addressing that, right? Like, they're just throwing all this, a lot of sport books are, throwing money at ads. So the ads are getting thrown up to people. And it's like, how do you say this ad is not healthy for me, right? Like, that is the problem that I have, right? Like, there's no way to report an ad as, oh, this is actually bad for me, like, or I'm not allowed to do this by law. Some judge has made a ruling, kind of thing. So
right.
There
are.
Yeah.
I was going to, sorry for interrupting. There are sometimes when you click off an ad, they'll say, what do you not like about this ad, or why are you not interested? So you can put that information there. That will get back to the company, whether it's Google or whoever is popping that ad up on whatever device or browser that you're using.
It's only Twitter. Let's face it, the only site I really use is Twitter.
Okay. But that is a really good point. I mean, what happens when those ads come up to somebody who's fighting an addiction?
Mm-hmm.
They're
that's harmful.
Who knows? yeah, it's not easy coping with that. I don't have a good answer for that.
Yeah, no,
Yeah, I mean, I don't think maybe it has been defined, but it's really whose responsibility is this, right? Is it, is it the person serving the ad? Is it the infrastructure? I mean, like, I don't know if we have an answer for that. Maybe we do. I'd love to, hear a comment in that regard. But to me, that strikes me as an incomplete solution to the advertising problem, right? They aren't considering the new flow of data as you interact with the system. Sorry, Audrey.
Yeah, I was just going to mention, but you have to remember too, with a lot of these companies, the reason some of their ads float to the top is they've actually paid for that content to float to the top,
right?
That you're looking at. So any, like, whether it's a social media company or just a web page browser,
right.
Remember there is payment for certain vendors to offer their services or their products. So there is a balance that company is having, and it's the bottom line sometimes, right?
No, I trust me, I completely get it. Like, I know that this wonderful service is that I use routinely is, I don't pay money to it, so it has to make money somehow. I get that, but there has to be a better way, right? Like, that's what I'm trying to say is, if someone from Twitter's out there watching, feel free to DM me.
They're just going to block you. That's what they're going to do. They're just going to block you.
I mean, and you know what? That's fine. I have a website. I can be deplatformed. I don't care. It's fine. It's just one of those things where it's like, I wish there was a better way for like add deterministic things to happen, right? Like, oh, he's literally blocked every single sportsbook account on Twitter. We probably shouldn't show him any more sportsbook stuff. Because they pop up every day. It's just a particular pet peeve of mine.
And so I think that goes back to this need for MLOps engineers, people that understand what the machine learning algorithm can do, what is other functionality that we need to bring in from other aspects of the system. Might be, it's essentially, you're kind of talking about just encoding a rule, right? Do not show Chris X.
Yeah.
And so then it's filtering those out of the recommendation and going back to the stakeholders and thinking, how will we know if we've done a good job? And I think everyone will know they've done a good job when Chris is happy.
Yeah. How do they know I'm happy though?
Can you let them know what types of ads you would prefer to see?
So I have gone through that data, and it's like, okay, yeah, I've cleaned up some of it because it was just like way off, right? Like, show me ads about the San Francisco 49ers. Like, I do not care about the San Francisco 49ers. No offense to anybody that's a 49ers fan. I'm not. So it's weird on what it picks up on, right? Like, it thinks I'm part of the Green Party, not part of the Green Party in the UK. I'm in the US, right? Like, it's really weird, but yeah. So yes, there are things that I can do, but when companies target specific demographics, that's where I find the problem, right? Like, is that the right way to do things? I don't know. To them, so far, yes. There is a money tree kind of thing to it, but there has to be a way to give feedback to that model to say, not Chris, or not people like Chris, kind of thing.
Right. Again, you're going into that whole topic where Carl is right. We could spend a whole couple hours discussing the ethics involved in the money flow and how certain demographics may or may not be targeted.
Yeah.
And yeah, that's the thing with AI. You have to use it ethically.
Exactly. All right. Any parting thoughts before we sign off here? No? All right. Well, thank you all for joining. Thank you all for watching out there. Coming up next on the channel here in an hour, going to be sitting down with some of our managed service folks to talk about managed cloud service offerings in the cloud. So should be a nice little conversation here at 11 a.m. Eastern, 1500 UTC. So feel free to join in, and you can catch this crowd again in a month. And then in 2 weeks, we'll have the data service office hour will contain data storage folks. So stay tuned, folks. It's going to be a fun ride. Stay safe out there, everybody.